Hello everyone, for this tutorial I'd like to explain how to figure out the limits of a function as x approaches positive or negative infinity. If we are given the function is a constant divided by x to the power of r, and we take the limit as x approaches infinity, we see the limit equals 0, and this is valid whether x is positive or negative, because as x tends toward infinity from either direction, so negative or positive, the limit must equal 0 because the function gets smaller and smaller as x gets larger and larger. This basic fact actually allows us to evaluate more complex functions, such as this one, because if we initially try x equals infinity, we get infinity plus infinity minus infinity, which is indeterminate, because infinity does not have a specific value, so we do not know what it will actually evaluate to. But what we can do is take all of the terms in either constants or x in the denominator by dividing by the power of x farthest away from 0. So this leads us to 2 minus 1 over x squared minus 8 over x cubed. We see the limit of what we factored x to the fourth power out of is 2, because it is 2 minus 0 minus 0. But the x to the fourth power, what we factored out, has a limit of infinity, and we remember an infinite limit times a finite limit is simply infinity. So that is our conclusion for what our limit is. If we have this limit, we can factor out t to the power of 5 as that is farthest away from 0. The limit inside is 1/3 because all the fractions are 0. And the limit of t to the power of 5 is negative infinity, so the overall function has a limit of negative infinity as well. We can take the limit of ratios of functions in generally the same way, by factoring out the furthest power from x in the numerator and denominator separately. And we see the furthest power from 0 is the same in both cases, so it cancels out. We are left with 2 in the numerator and negative 5 in the denominator, so our limit is a finite value of negative 2/5. It may be surprising, just by computations alone, that the limit has this specific value, but if you were to look at a graph, it would become more obvious why this is. Now that we've figured out more simpler types of limits at infinity that involve only polynomials and their ratios, we can look at limits at infinity of other types of functions next. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.